SynMax power steering fluid, designed for racing, heavy-duty extreme requirements in automotive, trucking, fleet, and commercial needs. This is a wonderful product. It's fully synthetic with aerospace base oils and hydraulic fluids, including the PolyX viscosity stabilization formulation with diamond-like additives for maximum protection and the lowest coefficient of friction available, including advanced aerospace anti-wear synthetic chemistry for premium hydraulic pump protection and performance, protecting the piston and slide areas, including conditioning for the seal and hoses to last longer. This allows the hydraulic power steering pump to have greater energy efficiency, providing more fuel economy with premium long life oil change intervals. SynMax power steering fluid will mix with current power steering fluids, either they're old or new, synthetic, or petroleum. Further, can be used as a lightweight synchromesh gear oil as an SAE 10 or other hydraulic needs, such as for a plow on a truck. For more product information, check out the SynMax videos and presentations. On this specific product, please review or download the brochure, technical data sheet, and MSDS documents. To find out how the Aerospace advantage for motorsports through diamond-like additives, providing the lowest coefficient of friction with the maximum protection in rolling and sliding applications, that is to follow. Hello, this is Clayton Balmas, and I'm your teacher today here in our audio classroom here with SynMax University, available at synmaxperformancelubricants.com. Today we're going to be sharing with you what I consider the crown jewel presentation for the SynMax Performance Lubricants line. It's the diamond-like additive performance data presentation. And so I hope that you enjoy listening to this as I enjoy sharing this with you. And so let's go for a ride and see what we can find out, okay? You're going to like this. This is a DLA solid lifter performance. Now, a solid lifter on a cam we consider is the toughest metal-to-metal punishment known. I mean, that cam is going with a lobe, and on a flat tap, it's hitting a flat piece of metal. So there's a lot of technology involved to try to get that to work. That's why we always talk about the higher zinc levels. Well, it's more than zinc, and we're going to show you that. So this very same anti-friction theory and performance and durability applies to even your roller lifter and roller needle bearings. Say, why is that important? Because you got a little itty-bitty bearing that's got all that pressure on it that has to be protected. The camshaft, the cam bearings themselves. I guarantee you, when you've got a little bit of oil in that cam bearing, it needs help because all the pressure is on it as it's turning, as it's fighting to move the valve train. Piston skirts, your piston wrist pin, piston rings, cylinder walls, and other metal to contact friction surface areas. So get ready, you're going to enjoy this. Here we go. This was a solid lifter metal surface, okay? And it's going to show fretting on the left versus pretty much brand new. Now, what happened was both of these motors were run with 520 or 530 oil, I'm not sure, a NASCAR engine, okay? We're talking like, it was actually a 800 horse engine. It was a dyno run. And so it simulated in the dyno for 600 miles or 700 miles of operation. But here's what happened. On the left, the lifter on the left had micro fitting on the surface wear. Now this was from frictional heat. Okay, you see the crown that was there? See where the cam would stroke on the side, then it would hit the crown, then it would come off of the lifter. Now that's similar to a piston crown, and that's called fire flash degradation. All right, and then on the right you see the oil with the PolyX technology and the DLA technology. This lifter was like brand new. You say, does that make a difference? Well, we've got guys in short track racing that run about anywhere from 800 to 1,000 miles a year, and they're on their third year on their lifters. So the oil almost paid for the lifter. The cam's $1,500 and the lifters are 500. You're buying technology. You're not just buying a bottle with a label. All right. Now you can see the lifter on the right, the DLA additive allowed the surface to operate cooler with greater protection. How's that evident? Watch this. Now this is very interesting. Here's 50 times magnification of the lifters. Now the lifter on the left has what we call microfretting surface wear. It's from frictional heat or heat oxidation, which means thermal breakdown of the metal surface. Similar to a piston crown, the terminology is called fire flash degradation. What's actually happening is that these lifters are very expensive metal machining to get them to the point to handle what they do. I mean, you can see the machining scars that they do, and the reason they have those machining scars, like on the right, is so that those cross hatches are able to hold the oil, and then the oil that's held is supposed to protect that surface. So the additive package on the left obviously was not sufficient enough to do it. I might say, Clayton, I know what it is. You must have had your 1,500 points high zinc on the right, not high zinc on the left. That is not true. Both of these had a racing additive package. The one on the left and the one on the right. They had the same amount of zinc, I'll tell you that right now. But the one on the right also had an Aerospace synthetic zinc along with it for higher temperatures to run cooler. The one on the left would have had moly, probably 1,000 parts of moly and maybe 13 to 1,500 parts of zinc. The lifter on the right would have had the diamond-like additive package, the synthetic zinc, and multiplied together, it was over the 1,500. But this showed additive technology at the subsurface level. All right, because obviously something worked on the right. Now here you're going to see the metal fretting coming through. Now we're not coming against any company, but if these were your lifters, you really couldn't reuse the ones on the left, but you could reuse the ones on the right. Again, the lifter on the left, you could see where the metal started getting hot, it was exposing, it was opening up, and as the cam struck across it, it started to break off the metal. On the right, the additive technology, the Aerospace advantage, was able to stay in the metal and not allow it to break. The picture says it all right there. So here we've got a graft, and it took a lot of money and time to make this. But over here you've got your molybdenims, organomolys. These are the products that most of your race oils are going to be, or performance oils are going to be making out of. You know, whether it's Mobil or Schaefer's or others, they're going to be using some moly in their oil. Royal Purple, uh, Joe Gibbs. Yet over here, we've got the PolyX. Okay, so when they had like a wear scar testing, all right, it was a Phalanx pin V-block test for 1 hour with 500 pounds of load on it. Okay, the SynMax provided with the PolyX 58% more protection with less additive package used. Amazing. The other thing that's interesting is there's three diamond carbonates inside of the diamond like additives, which is basically for cold, medium, and then extreme duty conditions. It takes a little bit of time for them to soak in, about an hour. Once they finally soak in, you can see here in these cycles that in seconds of time down below, all right, that the coefficient of friction lowered to 0.14 coefficient, and that's pretty low. Moly is around 0.9. Here's an engine that was a super late model motor designed for the CRA series rules. It's 358 V8, 9-to-1 compression, and this is what we call a 4-barrel 390 carburetor motor. But with a special design, it's able to do 9,400 RPMs at 550 horsepower. Now, here's the deal. This is the camshaft. Now, there's two types of areas that we have on here. After 1,000 racing miles, the cam is still like brand new. You can look at the rollers, and it's like it wasn't even used. Furthermore, you can look at the slide areas of the roller uh, lifters in the slide areas where they go in the engine. They're not even barely touched. So this can be reused. You might say, Clayton, but I always thought on a camshaft it was on a solid lifter. Now we're going to get into that in a minute, in the presentation. But we also have to remember the little needle bearings and how much punishment that they go through as well. This is DLA technology in action. Another very important area is the piston skirt and the rod bearings. Okay, this is after 1,000 miles. Look at this skirt. It's like brand new. It's like it was never used. Why is that, Clayton? You know, it's because the diamond-like additive technology got into this skirt and it just protected it. 9,400 RPMs, that's a long time. Now, I know these bearings are coated here, but you can see they're like brand new and literally could be reused again if the engine builder would choose to do that. Again, here's the crankshaft. Here's a couple of areas. Number one, here's the end of the shaft. Literally, this is a very expensive crankshaft, by the way. Um, the end of the crankshaft is still like brand new. And here's the main journal. Beautiful, beautiful shape. And that's what we expect from the diamond-like advantage for motorsport.